Today we will be studying torque. In pure translational motion, all points on an object travel on parallel paths. So in other words, when the guy jumps from here to here, he stays parallel to himself. So he moves the x and the y, but he's parallel. In reality, that doesn't happen. They actually rotate as well. Up until this point, we've assumed this happened. Now we're going to add this idea. So according to Newton's second law, a net force causes an object to have a linear acceleration. In other words, F equals ma. So what causes an object to have angular acceleration? And that would be a net torque, and that's what we'll be studying today. The amount of torque depends on where and in what direction the force is applied, as well as the location of the axis of rotation. So imagine we have a door, and it has a hinge on one side and a doorknob on the other. Where should we place this maximum force, and assume that the forces are all the same? Where should we place it, and in which direction should we push it to have the maximum torque? And this should be kind of common sense to you. You don't push on the middle part of a door or near the hinge to get it to rotate. You don't push into the hinge to get it to rotate. So the maximum torque will occur right here on the edge. So what is torque? Basically, you're taking this force and multiplying it by the lever arm. Now the lever arm is kind of tricky to understand, and we'll talk more about that in a moment. The units of torque are the force, the magnitude of the force, times this lever arm. So force is measured in newtons, and lever arm is a distance, so it's measured in meters. So it's a Newton meter. Okay. Since there's no like up, down, left, right with torques, I would like to talk about how we can determine which one's positive, which one's negative. So looking at A and B here, which one will rotate it clockwise and which one will rotate it counterclockwise? So A, as you can see, would rotate it counterclockwise, while B would go clockwise. Let's add a couple more. C would go counterclockwise, and D would go clockwise. So this is assume it's rotating around this fulcrum. So if you have clockwise and counterclockwise, and we had to add all these torques together, we have to have some way of determining which one's positive, which one's negative. We normally count clockwise as being negative, while counterclockwise as being positive. So both A and C would have a positive torque, while B and D would be a negative torque. All right. Let's talk a little bit more about this line of action idea. Since this force is perpendicular to the axis of rotation, this whole length is the lever arm. But this distance is the lever arm in this case. So how is that so? How does that actually happen? All right, let me stop the PowerPoint for a second and show you what I'm talking about. Now, here's the force pulling up this way. Not all of this force is going to get it to rotate. So what we need to do is find out how much of this distance is actually going to be part of the lever arm. So all you do is take it, and you rotate it until this and this become parallel. That's going to be perpendicular. And that would be the lever arm distance. Okay? And in this case, since the force is pushing directly on the hinge, it doesn't cause any rotation at all, because you know that if you're trying to open a door and you push it on the hinge, that's not going to get it to open. Okay? Okay. Torque depends on three quantities: the force, the length of the lever arm connecting the axis to the point of force application, and the angle between the lever arm and the force. As you can see in these cases here, this would give you maximum torque, assuming all the forces are the same and the wrench stays the same length. This would give us maximum torque because the lever arm is maximum. The force stays the same, and this whole length of the wrench is the lever arm. In this case, the lever arm is reduced because of the angle that you're pushing it on, and it's reduced even more here and even more here. Okay? So let's try an example. This is the Achilles tendon. The tendon exerts a force of magnitude 790 newtons. Determine the torque, magnitude, and direction of this force about the ankle joint. So here's the ankle joint. Here's where the tendon attaches. The first thing we're going to need to do is determine the lever arm. So we know the distance between the ankle joint and where the tendon attaches is this distance here. So if we take this distance and we rotate it until we just rotate it up until we get a 90-degree angle here, then this distance here will be the lever arm. When that happens, this angle here is 55 degrees. So, if we know that this distance here is a hypotenuse, this is the adjacent, and we're trying to find the adjacent, we could find the length, which is the adjacent length. So solve that for length. That will be the length of our lever arm. The torque is equal to force times lever arm. So we can put it into our equation and solve for the torque that was required.